Here we have a fairly tricky modeling problem. This question says an electric company is building power lines from point A to point B. I've labeled point A and B with the white dots. The company must build across unpaved terrain to reach the road, then build along the road. The section of this labeled with the letter C represents the section that's built along the unpaved terrain. The section that's labeled with X represents the part that was built along the road. Building on the unpaved terrain costs $4,000 per mile, while building along the road costs $2,000 per mile. We are also given that point B lies 5 miles south and 10 miles east of point A, which is represented by this white set of lines that I've labeled with 5 and 10. Our job is to write a function to calculate the cost of building those power lines. First, we'll need to figure out how to represent the lengths of B and C. Notice that B and X are along the same line. So we could say that B plus X together must equal 10. If we're going to try to solve for B, what we'll need to do is subtract X from both sides, meaning that the piece B will equal 10 minus X. This will tell us how long this piece that I'm indicating in red is. We'll write 10 minus X underneath that B. We can use that 10 minus X to help us get the length of C. You may notice that we have the shape of a triangle on the left part of this picture. We have a vertical side that is 5 miles long, a horizontal side that is 10 minus X miles long, and then a diagonal side, which is C. We don't know what C is yet, but you can use the Pythagorean theorem. We can say A squared plus B squared is equal to C squared. Our A will be the vertical side, that's 5. We'll begin by saying 5 squared. Side B is a binomial that's 10 minus X. It will be squared also, and that will equal C squared. We can simplify this binomial squared by rewriting it as 10 minus X times 10 minus X. We'll add this to 5 squared, which is 25. Then we'll use the FOIL method to multiply these binomials together. We'll take that starting 10 times 10 and minus X, and then take the negative X and multiply it by 10 and another negative X. We'll start with the 25 and say plus 10 times 10, which is 100. 10 times negative X is minus 10X. Negative X times 10 is another minus 10X. And then negative X times negative X is positive X squared. We'll set all of this equal to C squared now. Then we combine our like terms. We'll take 100 plus 25, and then also negative 10X minus 10X. So on the left side, we'll have X squared. We'll add negative 10X minus 10X gives us negative 20X. And then 100 plus 25 is positive 125. We'll set this equal to C squared, and so therefore C will just be the root of that polynomial. Now that we know the distance for B and C, we can begin to calculate the costs. On this new slide, let's write down our distances and then write down the costs. We're looking at both unpaved and paved road. The cost of building on the unpaved road was $4,000 per mile. The cost of building along the road was $2,000 per mile. And now our distance we'll have to write down too. Our distance for building along the unpaved road was this root function that we wrote previously. Square root of x squared minus 20x plus 125. The distance we're paving along the road is just going to be x because that's this green line that is between this triangle and point B. Now we multiply the cost times the distance. So for the part along the road, we'll say the cost is 2,000x. We'll add that to the cost of the unpaved road, that's 4,000, times our square root of x squared minus 20x plus 125. We're going to bring that cost function into the next part of the question. Since this is not a simple second power function, you haven't learned how to maximize or minimize this yet. In MAT-171, we're not going to ask you to learn how to minimize or maximize this combination function by hand. Instead, for questions like this, it's okay to go to technology or to a graphing utility. Here in my graphing utility, you can see that we have a slight minimum at around 7.11. We'll copy this over into our presentation. Copied from our graphing utility, the x value will be the distance we're traveling along the road, while this other number, this 37,320, will be how much it will cost. Therefore, we'll say our minimum cost is $37,320.51 if we round. This comes from an x value of about 7.11. This means if we build 7.11 miles along the road, that's going to give us our minimum cost.